All right, guys, in this video, we're going to be looking at concentration over time. This is talking about reactant orders, identifying what the reactant order. And before we even get started, remember, it's all about finding the linear graph. So if the linear graph is just a concentration of whatever it is, and it's linear, then that would mean it's 0th order. If it's the concentration, the natural log of the concentration of whatever it is, and it's linear, then it's first order. And if it's 1 over the concentration of whatever it is, and it's linear in a positive slope, then it would be second order. So this is the generic trends that we're looking for. And really, if you can remember this, you can solve pretty much every one of the questions that it could ask about that. So, looking at this question, and it's pretty wordy, but essentially what it's asking for is looking at the graphs and using the graphs to identify what order of reactant. In this case, it's blue food coloring. Which one is it? So based on the graphs above, we've got 3 options here. We've got just the absorbance or the concentration. We've got the natural log of the absorbance, and we've got 1 over the absorbance or concentration. Based on the graph, what is the order of the reaction with respect to blue food coloring? Okay, remember, since the linear graph is associated with the natural log, that's the one that's linear, we can assume that this will be a first order reactant. Okay, and you can explain it. You can say how because we have a linear graph or a linear slope with the natural log, we can get first order reactant. Probably something else I should say. This is absorbance, so that might not seem like concentration, but remember, absorbance and concentration are proportional. They're directly related to each other, so you can substitute them and they will be just fine in terms of graphing, and that's why we can use these graphs. So graph 2 tells us that this order of reactant is first order. Okay, looking at this next question, and it's multiple choice, but we'll leave the answers for later. We've got a reaction. We've got NO2 and CO. They're combining to make some products. A group of students studied the rate of the reaction, represented above, at a fixed temperature. During the reaction, the concentration of CO was in large excess. The graphs shown below were created using data collected by students. Based on graph, what is the rate law? Okay, a couple of key things. The rate law should include both reactants, but since the concentration of CO was in large excess, okay, that's telling me that that's a 0th order reactant. It's really, there's so much of it and the rate is changing. CO is not going to be affecting it, so it should not be part of your rate law. So, and you can see in our answer choices, they don't even put it in there because really, we're just looking if NO2 is a 0 first or second order. And what's the difference between these two? Oh, this one's wrong, right off the bat, because there's no K. They got to have a K, they got to have a rate constant. So B is wrong right off the bat. All right, so looking at our graphs, this is a 0th order, this is a second order, and this is a first order. Okay, I like to do that just right off the bat so I don't even get confused. I know that if it's just concentration, it's 0, if it's 1 over, it's second, and natural log, it's first. Notice they kind of put it in a different order, probably trying to trick us. Maybe think it's 0, 1, 2. Make sure to look at what it is looking for, or what is the actual calculations that are going on right here. So which one is linear in the correct way? It is this one. It is second order reactant, and it's linear, and it's linear in the positive slope, which is great. These two are not linear, so this is clearly a second order reactant. So we're going to look down here and find the correct answer, and that would be D. D shows us that NO2 is a second order reactant. This one just shows us it's a first order reactant. This one's not any good because it forgot the K, and this would only be true if it was a 0th order reactant. So this answer is D. Hopefully that was helpful.